right, ladies and gentlemen, we're going to start our lesson about domain and range, which are two fancy-looking math words, but really they just mean the x's and the y's. Spoilers, but yeah, that's all it is. So, yeah, if you are given a set of points, you're given a graph, if you're given a table, and you're supposed to write down what the domain is, what you're doing is you're writing the x's. And there's a few rules about writing this down, and they are write them least to greatest. And I ran out of space because I'm terrible at judging that. So you're writing it least to greatest, and don't put in repeats. So no repeats. And so I'm going to write down the domain of this little function here, which has 4 whole points. And so I'm going to write them all down. I'm going to write the lowest x value, which is -3. And then it's -2. And then -1. And then 3. And you may have noticed I put these in least to greatest, but they also showed up least to greatest here. And I need to look through and see if I have any repeats, because you can't have any repeats, and there aren't any. So that's my domain. And if your domain is just a set of different values, set of just single numbers, you're going to put them in what I call a squiggle bracket, which are these things here if you're looking at an actual font. But yeah, you got the squiggle brackets. And you put in squiggle brackets because it's just those specific numbers. Alright, now let's move on to range. Range is a companion to domain. It's the y's of your function, or the possible y's. And I'm going to start with the squiggle bracket, which is just like a terrible 3. And I'm going to look at my y's. And much like my domain, I want at least to greatest and no repeats. So look here, I got 4, 4, -1, -1. So I'm writing them least to greatest, -1's the lowest, and then 4 is the biggest. And I'm not writing the repeats. So there is another 4 here and another -1, but I'm not going to put those because you don't put repeats and you put them least to greatest. So my range is actually only 2 numbers, and my domain happens to be 4 numbers. And that can happen. Sometimes your domain's not the same size as your range, and vice versa. Well, you can also get domain and range from graphs, like this one's nice and smooth and continuous, and it would take a long time to write down all the possible x values, because this has an x value of 5 and 6 and 7, but also there's this point here in the middle, like 5.3, that's also one of the x values, and then you got x values like 11.592, and there's just happens to be infinitely many x's on my graph here, and especially because if it keeps going like this, yeah, you're going to have a hard time writing all your x values. But luckily, over here, it does end, so my x's, my domain here, they start at 0, and they continue on right forever and ever and ever, because it has an arrow, so I'm going to put infinity. And I'm going to put some brackets on here. On infinity, you put an open bracket, and on 0, you put a closed one, because it actually hits 0. And now, time for the range on something like this. I need to think about what's the lowest y value anywhere. Well, you don't want to look left to right, because that's not the lowest y value. The lowest y value is going to be over here if it goes down forever. So if you go down forever, eventually this is going to hit negative, and then it's just going to keep going and going and going. So my range actually goes down forever, down to -infinity. And then you want to write down what's the highest y value, which is up here, my highest point, which it looks like that's at 100. So I'm going to put 100 for my range, ending there. And I need to put my appropriate brackets on it. It doesn't actually reach infinity or -infinity, so you're going to put open, but it does actually hit 100, so I'm going to put a square bracket there. So you kind of get a difference here, right? When it's just individual points, you just write down the individual numbers. But if it's a graph and it has infinitely points on it, you're going to use these intervals that we've been learning about. So let's actually dive into answers on your assignment. So we'll do a few examples. So Let's say we have this one. I want you to try writing down the domain. Remember, it's the x's, and put it least to greatest with no repeats. So pause and do that. Did you get 5? That's a bad squiggle bracket. If you did, congratulations. If you didn't, it's just 2 and 5. Right? You got 2, 2, and 5. There's a repeat of 2, so we don't write 2 twice. And 2 to 5 is least to greatest. So give the range a shot. What are the y's? Again, least to greatest, no repeats. Alright, did you get -3, 5, 7? If you did, congratulations. If you didn't, remember we're writing least to greatest and no repeats, and the ranges of the y's. So we got 5, -3, and 7. Rearrange it so it's least to greatest. And then the next part, it's asking you if it's a function. And the definition of function is each x is assigned exactly 1 y. So you have to look at your x's and think about, well, how many y's got paired with my x's? So 2 got paired with 5, 2 got paired with -3, and 5 got paired with 7. These are pairings these y's got assigned to those x's. Well, if you look at this one, 2 got assigned to 5, and 2 also got assigned to -3. So 2 has different y assignments. It has 2 of them. And so that would make this not a function. So, and that's because 2 has 2 different assignments. If this number was anything else, say it was 1, if this was a 1 instead, and instead my domain was 1, 2, 5, then it would be a function, because 2 got assigned to 5, 1 got assigned to -3, and 5 got assigned to 7, and that would make it a function, because each x has only one y assigned to it. Alright, let's jump down to a different one. Here's 5. This one's just on a grid, but it's the same idea as what you're looking at. It's a list of points. This has coordinates. It's at -3, 2. And this has coordinates. It's -2, -3. And yeah, if you find it helpful, you can write out the coordinates for these, and that can kind of help you write down your domain range. So I went through that. Go ahead and write down the domain and range, pause the video, and see if you can get it. Alright, let's have you check and see how you did. On domain, did you get -3, -2, 1, 3? If you did, awesome. Those are the x's. The x's are just -3, -2, 1, and 3, and you write them least to greatest. There's actually no repeats, so that's easy. On the range, it's only 3 numbers, even though there's 4 points, and that's because the y values down here for both of these points are the same. They're both -3, and we're not going to write -3 twice. You just write it once. And then we got a y value of 1 and 2. So least to greatest, -3, 1, 2. And now for the final part. Is it a function? So remember, the definition of function is each x is assigned to exactly 1 y. So I want you to put a guess down. Is this going to be considered a function? Sometimes people get tripped up on this one because there are 2 points that have -3 as the y value. But this definition only goes one direction. Is each x, as in -3, -2, 1, and 3, assigned only one y value? Yes. 3 only got assigned, -3 got assigned to one number, -2 got assigned to one number, 1 got assigned to one number, and 3 got assigned to one number. So each x here only has one assignment. So yes, this is a function. But I hear people saying in my imaginary classroom, but this has -3 got assigned to 2 different x's. That is totally fine. All of the y values on our function can be the same number. In fact, that just makes a horizontal line. If every single x value, say 10, got assigned to a single y value of 5, 4 in this case, that would be totally fine. Each x only has one y assignment. And so this one is a function. If we were to look at a slightly different one, say this one, these 2 points Now we got 0, 1, and then 0, negative 2. This would not be a function because 0 got assigned to 1, also got assigned negative 2. So there's 2 y's for 1 x. On this one, you got 2 x's for 1 y, and that's totally fine for it to be considered a function. And if you really want to giggle, you can imagine y's as wives. In our current set of laws, it is illegal for one x to have multiple wives, but it's okay for a single wife to have multiple x's. And so if that helps you out, you can think of it that way, and that's how it works with functions. One y can have multiple x's, but one x can't have multiple wives. And I just want to point out a couple of these other ones. We actually kind of showed you an example of this earlier, but if you have a graph looking like this, it has a definite x starting value, which in this case is negative 3. And then since this has an arrow, it continues on forever to the right. And so we're going to write an interval instead of individual points. Since this is open, we're going to have an open bracket on the negative 3, and it's open on the right side because you never actually reach infinity. And then this has a definite y starting value, which happens to be 1. And it goes up forever and ever and ever. But again, since this is open, we're going to have an open bracket on the 1. We're going to use intervals because there's too many points to write down. There's infinitely many of them, and we can't write them all down. And then another part here, if you remember our last unit, this is going to say g of negative 4. That means the y value when x is negative 4. And so this should be a breeze. If you look at your points, you can find the one where x is negative 4. Oh, there it is. And you find the y value that goes with it, which is negative 1. So write down negative 1. So there you go. Good luck on this. Hopefully you're understanding the difference between domain and range and how to write your answers down.